Hello and welcome back. Alright, in this video we're going to talk about how we take our main CPP file, or our programs in general, how we take the code of that and how we actually turn that into an executable. So if we start off with our main CPP file, you may remember last time that I said that there was this thing called the preprocessor. So that's the first thing that's going to happen. This preprocessor. And so what this does is, depending on the preprocessor directive, it'll perform different operations. But essentially, the preprocessor just does direct text manipulation to your C++ file. So when you see the pound include IOStream, for example, the preprocessor actually rips this line out of your C++ file and copies the entire contents of the IOStream file into your program. So one thing you need to be aware of is that you don't want to include the same file multiple times. There are tricks that we can do to ensure that that doesn't happen. You don't want to include files that you don't actually need because it will bloat the size of your program. But yeah, so that's basically what the preprocessor does. It actually just does a straight up text manipulation on your file. And so that's going to actually create you a new file. We'll just call it main.cpp. Alright, and so from this place, this is where we actually start getting interesting. There's two phases that come after this now. So we have our new C++ code. Next thing we're going to do is we're going to send this into what is called the compiler. So I should put a box around the preprocessor. Alright, so the compiler, what that does is it actually turns your source code into actual instructions that the computer can run. And the outputs of those look like main.o or main.object files, just depending on the platform that you're on. And so this is actually machine code that could be run, or that will be run, to execute the contents of your C++ file. The next stage is what is known as the linker. And the linker is what takes all of your code that got compiled in this phase and mashes it all together and creates your lovely program. So in this case, we actually only ended up with one object file, so there wasn't a lot of mashing that it needed to do. But let's say we had an example of a program where we had a main.cpp file, we had a foo.cpp file. Okay, so after we go through the preprocessor and it massages the C++ files, we go through the compiler. The compiler creates object files for each of your C++ files. So we have main.o that gets generated and foo.o that gets generated. Your linker comes along. Here, we'll put a big C here for compiler. Your linker comes along. It takes both of those object files, mashes them together into a single file called, well, you can change the name, but for this example, program.exe. So that process of linking right there, that is known as static linking. Static linking is basically when you take all of your object files that you depend on and put them all into a single executable file. There's some benefits for static linking. One of which, all your requirements are always there. let's go ahead and take a look at the next type of linking that we can do. So let's say that we have a, um, well, if we're including the IO stream, what's going to happen here is that we're actually going to get some dynamic linking. So we don't actually own the code or the object file for this. So let's use this example again. Main.cpp, foo.cpp. Well, let's actually just do this. And we'll have a library.cpp. And this line, these are going to be two different projects. All right, so this is going to be project 1, and this is going to be project 2. All right, so when we go through the compile phase, up here we get main.o and foo.o. Go through the linking phase, we get program.exe. All right, so down here we go through the compile phase, we get library. Oops. Library.o. We'll go through and link them. And we've set up our project here to actually, instead of creating an executable file, we're going to create a DLL file. A DLL file is a dynamically linked library. Basically, it's a block of code that can be shared among different programs. And so in this case, we have our program executable, our CPP, our library CPP for our program 2 library file. Well, the linker actually in program.exe up here, we said that, hey, we're going to need this file. So the linker says, you know what? There's actually this DLL over here that I need. And so it kind of references this DLL, but it doesn't actually inject the library code into a program. That doesn't happen. So now you have these two object files, essentially, lying around. And so this is what's known as dynamic linking. Alright, so now there's benefits to dynamic linking and there's benefits to static linking. Static linking, you get all your object files into one executable. You can copy and distribute that around pretty easy because there's only one executable file. You might have some extra resources like images or text or whatnot, but there's only actually one piece of code that's being run. In the dynamic linking case, you have multiple components that you're going to need in order to run your program. Now, this component actually might be a system component, so it could be shared on the system. So it could be a system component. It could just be a user library that's someone else, and so we'll just call that a user component. So one of the dangers of dynamic linking is that you might have linked to version 1.0 of this DLL. But on the computer that you've distributed your program to, you know what? They might have version 2.0. Now, this may or may not be a problem. If the code that you call from your program executable, if the code that you're calling from there that's in library DLL, if the signatures of the methods didn't change, basically, then you'll be okay. You won't have any problems. Your program will run. It'll pick up the new DLL totally fine. So that's an easy way to get patches to external DLLs and fix bugs, fix security holes. That's all great. The problem is when something does change that your program relied on. Maybe they got rid of some code that that you called. Well, that's going to be a problem when your program actually tries to load that DLL and run it. Your program will crash. The library might have the V1 library might have had a specific bug that you actually worked around, and in V2 they might have fixed that bug. And if that happens, then your workaround is probably going to fail, and so your program is going to fail. But this time it's not going to crash. Well, it's not going to necessarily crash. It's going to maybe continue on and pretend like everything's okay, but it could expose new bugs into your program. So this problem has had an affectionate name for it. It's called DLL hell. Managing different versions of DLLs. And so each system kind of does that differently. But and sometimes you can link to specific versions of a DLL, and sometimes you just kind of get stuck out in the land of plain version number and hoping everything works great. But really, that's all there is to moving or transforming your code into an executable. There's really just two phases. Well, there's three. There's the preprocessor, but that's really just a text phase that doesn't do anything terribly interesting. It just saves the programmer a lot of work. Like, for example, these pound includes. I could have manually copied an IO stream to my file and done that, but that'd be a pain in the butt. The next two phases are the actual interesting thing, and that's the compiler and then the linker. And so you just got to remember that the compiler turns your source to an object file, and the linker mashes your objects. Oops. So that's that for this video. In the next video, we're going to go ahead and take a look at two of the more common IDEs, and we'll see how most of this stuff just actually happens in the background for you, and you don't have to actually do anything. Thanks.